Hi, everyone, and welcome to Getting Started with Edge Impulse with Jim Bruges. Jim is a seasoned staff solutions engineer here at Edge Impulse, working with customers across industries, including healthcare, industrial IoT, wearables, and more. Jim has seen how Edge AI can be brought into today's products to provide valuable insights and meaning to the data these devices produce. By applying his previous experience in a wide range of engineering disciplines, including 4 years at Dyson, he advises clients about AI at the edge and is an expert in edge use cases. While Jim is presenting, feel free to put your questions into chat, and I'll do my best to get them answered for you while he's going along. And with that, I'll turn it over. Take it away, Jim.
Thanks, David. Really excited to be here today and give you guys a little overview of how you can get started building Edge AI models with Edge Impulse. So we're just going to run through a couple of slides to get started, and then I'll show you how you can create your account for free and then create your first ever Edge Impulse model, and we'll go through it together. As David said, if you have any questions, leave them in the chat, and there'll be some time at the end for us to answer them as well. So, as I said, the agenda for today is to give you a little overview of what Edge AI is as a kind of field, and then we'll give you a quick introduction into Edge Impulse. So the first thing I want you to think about is, what does the real world look like? When I'm talking to my customers, I always start with this. We all have a number of senses in our body: smell, touch, sight, taste. But we don't necessarily think of those senses as raw data. Our brain does a lot of interpretation of that sensor data that we're getting from all of these different limbs and sensors in our body and turns it into useful insight. So when you look at that picture on the right, you can see that it's a bottle on a production line. Or when you hear a certain noise, you can hear that it's your dog barking or your cat meowing or a particular person saying a word. Or even if you're on a train and you feel the tracks vibrating, you can tell that that's where that vibration's coming from. All of that is what we call inference. And IoT is in a similar position. We have lots and lots of different sensors out in the world, but what we're lacking is that ability to add the insight to those senses. So what Edge AI can do is help you bring that special insight that humans have to that sensor data directly at the point of data collection to help you create really intelligent systems. So traditionally, in order to add that intelligence to a system, previously we would have used a traditional programming route. So we would take some data, some sensor data, apply some rules to that data, so maybe a simple threshold or some more complex stuff with heuristics, and then we would adapt those rules until we get the outcomes that we're looking for. So, setting a threshold on a particular sensor so that you get an alert when something goes above a reading, so that you can go and make some action. What artificial intelligence allows us to do is take sensor data plus some known outcomes of that sensor data, and then use special artificial intelligence training algorithms to then create the rules without us needing to program them ourselves. So we create an artificial intelligence algorithm so that when in the future you present it with new data, it's able to tell you what the outcome should be. This is super, super powerful because it reduces the development time for a lot of these use cases and actually opens up a huge number of new different avenues for creating insights out of sensor data. So what can AI look like in the real world? This is a nice question to ask yourself when you're starting to think about what you could build with Edge Impulse. Over the last year, you might have seen a couple of these products in the news, a couple of these kind of more hype-based AI products. And I think that this is not necessarily what we should be looking at when we want to build AI into the real world. That's really just shoehorning a couple of kind of cool features into a device to make something happen. But in my opinion, what AI looks like in the real world is it's actually pretty invisible. It's part of a larger system that helps solve real problems. So we've got a couple of examples here in the kind of more industrial space. Power line monitoring. We've worked on a project to use vibration to detect faults in power lines. Object detection in factories, for example. Wildlife monitoring with drones. All of those things are things where you could traditionally just send the sensor there and then take the data back and do something with it. But by having that intelligence at the edge, you get a huge number of benefits in terms of latency, reliability, privacy, things like that. Then on the other side, AI can be part of real consumer products. So these are just a couple of products that people have been working on building Edge Impulse into. We've got some headphones there from HP, Poly, where they have a keyword spotting algorithm developed in Edge Impulse. We've got Polar watches. They're working with Edge Impulse to develop new algorithms. Ultrahuman are using our HRV algorithm in their rings to give you really accurate health data. No Labs are working on some really cool stuff in the healthcare space. These are all devices that don't necessarily look like they're AI devices. But with Edge Impulse, we're able to bring AI into them in a meaningful way that helps solve an individual problem. And that's really the thing that I focus on most when I talk to my customers. It's about solving really discrete problems that otherwise would be really difficult to solve with traditional programming, or are much quicker to solve with AI because you have a lot of training data available. So now that we've talked a little bit about what AI is and why you might want to put it onto an edge device, let's talk about how you can build your own models. So Edge Impulse is a great platform for getting started and learning the basics of AI, but also going all the way to production with real-world production use cases. But to get started, you can sign up for free today for our community plan. You get a real wealth of features that help you start out with your Edge AI journey. So the first thing I encourage you to do is scan that QR code on the left or head to studio.edgeimpulse.com/sign up. And it will encourage you to sign up with your Google account or with GitHub, or enter your email and a new password there. All you'll have to do is just accept the terms of service and click the link in your email to verify your account. Then you should be taken through to our welcome wizard. So there are two options. And today we're going to be walking through the audio keyword spotting wizard, and I'll be building a model with you today. But we also have a really interesting image classification model wizard, which can help you work with image data. The nice thing about these getting started guides is that they can use the microphone or camera in your laptop or your mobile phone to collect data. So you don't even need to have any hardware, and we can also deploy back to those devices to test. But Edge Impulse, as I'll tell you in a second when we go through the demo, gives you a huge range of different edge devices you can deploy to. So that's if you're signing up from scratch, but I know some of you will already be members of the community tier of Edge Impulse. And if you wanted to get started with the wizard yourself, what I can tell you, all you need to do is create a new project, and then in the project dashboard, head down to the danger zone at the bottom of the page, and you can click the launch getting started wizard, and it will kick off that wizard for you again and allow you to create your first project again if you've not had the chance to do that before. So now that we've talked about the admin, let's jump into Edge Impulse and have a go. So I've just clicked the Get Started in Edge Impulse, and I've been greeted with this lovely set of fireworks. And I'm going to click this button, and we're going to walk through together our first model in under 5 minutes. So the first thing we need to do is choose for this keyword spotting project what we want to detect. In this case, I'm going to take the namesake of our conference, Imagine, as our first keyword, and we'll use that to collect some data. Traditionally, you can also bring data across from real devices in the field via our API, or directly from your desktop, or if you have time series data, through our CSV wizard for helping you set up rules for importing continuous time series data. But today we're going to use the built-in web collection tool to collect some keywords. So all I have to do now is click this button, and then it'll bring up a wizard to help me record my data. And now forgive me, you'll have to wait while I say the word imagine 38 times in a row. Imagine, 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 imagine. Okay, deep breath there, but thank you for bearing with me while I said imagine all of those times. What we're doing there is collecting some training data. So this is data that allows the model to understand while it's training what we're looking for. And the tool that we have here is really simple. It records all of that data and cleverly splits it all up into all of these data samples that you can see in the background there. We'll have a look at that in a second. But now that we have our words that we want to detect, one of the key things that you need in order to train a machine learning model like this, where we're trying to detect between the word imagine and everything else, is the everything else. So we also need to mix in some unknown keywords and also some background noise. Now, we've got some pre-built data sets for unknown and background noise, which are available in our docs. And I'm mixing those in now just automatically. So now we have enough data to train our model. And I'll just show you around quickly. So if we look, we have our training data set with 338 samples, about 2.5 minutes of unknown data. If we look here, just some random words. And then we have some noise data, which is just random background noise. And then we have my lovely imagines. Imagine. Imagine. One thing to consider here is that you may need to have a real diversity in the voices that you're trying to detect. The model that we're training today is likely to work best for my voice because I've used it myself to train to record all of these words. So if you were developing this for a real production application, you would want a breadth of different voices, high-pitched and low-pitched, slower, faster, to give you the breadth of training data so that the model can learn that pattern best. We also have some tools which probably our colleagues will touch on in later sessions for generating synthetic data, and voice is one of those things that we can create really good synthetic data for these days. So that can be a great way to quickly bolster your data set. You can see here we've also held back 87 samples for our test area. Now this won't be used for training and will be unseen data that we can validate that our model works well on. And you can see we've got an 80-20 test train split there. That's a really important figure for kind of good quality training. So let's continue with the wizard now that we've got some data. The next thing is to design your impulse. So I'll explain what's going on here. The impulse is basically everything that we're going to give you that will run on your end device, but we configure it now while we're training. So on the left-hand side is our sensor. In this case, we're looking at an audio sensor. Edge Impulse also supports any time series data and images. And we're choosing a window size. So this is how much data we're going to feed into our model each time we run it. We're feeding in 1 second. Your window increase, the stride, is how much you're going to shift in time between each time you pass data into the model. For keyword spotting, it could actually be wise to use a window stride less than the window size so that you have a bit of overlap. In this case, I won't, just for the wizard's sake, but if you say had a word like imagine and it was caught between two different windows, so the first bit got ima and the second bit got jin, then you wouldn't detect that word. But if you had that window overlap, then one of the windows that was overlapping would have caught that word. So that's why that window increase is important for event-based models. Your sampling frequency is generally determined by the sensor you're using. We can up and down sample if you use different sensors for training and deployment. Zero padding your data is just if the sample is too short, whether we add zeros onto the end. That can be important for more continuous models where you're not expecting to see nothing. You're expecting to see a continuous stream of data. So bear that one in mind. That can really affect real-world performance in certain circumstances. The second stage is processing. So one of the ways that we make models really small to fit onto edge devices is by reducing the dimensions that go into our model. And one of the ways that we do that is by using clever digital signal processing techniques in the pre-processing step. So we have a number of different algorithms here that our DSP team have put together, which make it really easy to extract things like the frequency and power components of your data, rather than feeding the full 16,000 hertz of data into the model. And that can give you huge benefits in terms of model size, because these algorithms are much simpler than the machine learning algorithm. The final step is our learning block. So in this case, we're doing transfer learning based on a larger keyword spotting model, but Edge Impulse also supports classification. So any kind of classification model, neural networks, classical ML models. We also support regression for getting numbers out of data. So if you wanted to create a virtual sensor, that would be really useful. We support anomaly detection models for where you might have only known good data and no known bad data. And that could be really useful for things like fault detection. And then for vision, we also support object detection and visual anomaly detection. Those are also great model architectures too. And within each of those, we support a number of different model types. So that's what the impulse is. And on the right-hand side is our output. So we're going to be getting an output which determines whether the sound that we're passing in is an imagine, a noise sample, or an unknown sample. So let's go on and generate our features for our spectrogram. And then while that's running, I'll just explain what's going on here. So what this is our pre-processing step. And as I mentioned before, this is a way that we convert our raw input features, 16,000 of them for 1 second, into some process features, which are only 4,000 or so. So we reduce this by a factor of 4, which reduces the complexity of our end model quite a lot. The other thing that we can do here is add in something like a low pass or a high pass filter to remove noise, and that can improve the accuracy of your model as well. And focus on particular frequency bands where we know that, for example, human voice is. So we're really focused on the kind of human voice frequency bands, and we can look at some imagine samples here. You can see that this is kind of the signature that we're learning the pattern of. We also have an auto tuner here, which can help set these parameters for you if you're not a DSP expert, which I'm certainly not. So I make use of this all the time. So all we've got to do is wait for our features to be created. And what we're generating here is basically all of the raw data is being converted into that spectrogram format so that we can then pass the spectrograms into our machine learning model for training. And what we'll get out in a second is a really nice map of all of our data in a 2D dimensionless plane that shows us the clusters of our data. And that can be a really good early indicator of whether or not you're going to be able to train a machine learning model to sort of figure out the thing that you're trying to figure out. We'll see that in 1 second once this is finished generating. I have to bear with me. My machine is being slow this morning. One thing that I can touch on here while we wait is that all the way through the platform, you might have noticed this target in the top right-hand corner. We can choose a really wide range of different hardware targets. So say we were interested in profiling this model for a Nordic NRF53. We could choose that, and then each step of our model, we can get a benchmark for how much RAM and latency it will use on that particular target device. So if we choose that, we can see that the pre-processing step is going to take 18 milliseconds and 20K of RAM on this Nordic NRF53. But we could also look at a custom device. So if you had a particular processor that isn't listed in that list, you can choose a Cortex-M, say it's an M33. We know that the clock rate is 120 megahertz, and we have a U55 accelerator, for example. You can set up a completely custom one and see how that affects your pre-processing time. And that could be really useful for giving you an idea while you're developing whether or not your model is going to fit on the end device. So I mentioned before that the feature explorer is shown here. You can see we've got really nice clustering of our imagine samples, and then our noise and unknown are over here, which we are not so concerned about. But this separation is really good. It means that we're probably going to be able to create a model pretty easily. So let's go on and train our neural network now that we have our features. So while this is training, I'll just explain what's going on here. So for this model, we've chosen to do transfer learning. So this is taking a pre-trained keyword spotting model that is much larger and then fine-tuning it with our own data to be really good for this particular set of keywords. And we have a number of different options here. down in the model, but we're going to use this MobileNet v2.35. And we're going to just use the default settings here while we're waiting. But we have some more advanced settings here for kind of setting your batch size or splitting on metadata keys. This can be really useful if you're trying to separate your data, make sure it's not leaked between classes. And if you're a more advanced user, you can even switch to the full Python code behind each of these models and look at the keras. So you could go in and edit this to your heart's content. And if you're really advanced, you can click this button to edit the block locally, and it will download the source code of a Docker container for this exact neural network. And then you can play around with it, add new parameters, add new training code, upload it back into Edge Impulse, and use it as a custom learning block in the platform. It can also be a great starting point if you have your own model architecture that you want to bring into Edge Impulse and use our training compute and guidelines to build a custom model for. That can be really useful. So while we're waiting for this model to quickly train, the other thing I'd like to show you is just that we can train models from scratch like this, but we can also convert pre-trained models that you've trained in PyTorch or TensorFlow or any model that is in the ONNX format, and we can try and compile that model directly down to run on device. So you don't have to just use our tools to train the model from scratch, although we recommend that because it gives you the benefit of having the full holistic view of how your target performs while you're training. We can also take pre-trained models and convert those down for the edge. So you can see now that we're training our model, and on the right-hand side, we can see the epochs rising, and that means each step that we're doing to train the model is getting better and better in accuracy. The way that some of these settings work is our training cycles is basically how long we want to train for, and the learning rate is how big a step we want to take each time to change the parameters to try and find the best performing model. If you think about it like a little man walking along a plane and he's looking for the absolute lowest point, but the lowest point might be in lots of different places. So he needs to walk a long way around and take big steps or little steps to try and find that lowest point. Then that's what we're doing there. So playing around with the learning rate can mean that sometimes you skip the lowest point or you get stuck in a low point where you shouldn't do. So sometimes it can be worth playing around with that learning rate a little bit. And I'll show you in a second what some of the tools that we have available to play around with some of these parameters in a more automated way look like. But while we're just waiting for this TensorFlow model to finish training, we'll see what it looks like in 1 second. So we're just converting the model now. I'll show you the Eon Tuner while we wait for that. So the Eon Tuner is one of the tools that we have available for you to kind of automate some of this experimentation process where you want to play around with a few different parameters. The defaults can be a really useful starting point, but say you wanted to go and dig around and see, okay, would my model perform better if I used a different DSP block, or I tried a different window size, or I tried a different model architecture? We have a couple of templates here, or you can build your own. You build this JSON format kind of template. When you click start, what we'll do is we'll set up to 10 or 20 trials all running at the same time with all of these different approaches. And then at the end, you get a really nice grid full of different approaches that you can then go and play with. And when you want to play with multiple different approaches in the platform, we have this experiments view. So I've created one experiment so far, but say I wanted to try a different approach, I could create a new impulse here and go and configure something myself, and then be able to go and see how those two different experiments compared in terms of their accuracy and their on-device performance. So let's jump back in. And now that we've trained the model, we can see what the training accuracy looks like. So with very little data, we've already got a model that's around 97.6 accurate on the training side with our initial data set. And the next thing to do is to test it on that unseen data that we had. So if we click continue in this wizard, actually, let's not do that. Let's jump to the model testing. We can test this data over the model itself and see exactly what the real world performance looks like. You can also jump in and look at an individual sample and see exactly how the model performs on that sample. So in this case, we've got one of my Imagine samples, Imagine. And you can see that we're looking at a 95% confidence that it's an Imagine sample. And you can even see where it lies on that kind of search space that we talked about earlier, this feature explorer. So it's definitely in the Imagine cluster. That's really good to see. So while we're just waiting for this model testing to finish, one of the things that you're really looking for when you're training a model is not just that these training accuracies are high, it's that you're looking for the model to perform well on data it's not seen before. Because one of the things that can happen is what we call overfitting. This is where your model actually only learns the pattern of the data set that you have, not the pattern of the general problem you're trying to solve. And this can mean that it has really poor real-world performance. And one of the ways you can validate that is by providing a decent amount of test data and validating that it really works on that unseen test data. So in a second, we'll see that this model does perform well on the unseen test data, 95% roughly, and that's pretty encouraging. And that means that this model should then, when we click Continue the Wizard, run directly in the browser as expected, and we'll be able to see it running live now. Now, what we're doing now is taking our model and building it to run in the browser using WebAssembly. And I'll show you in a second what the other different options for running your model look like. But the nice thing about this browser view is that you can use your microphone on your laptop and immediately test out the model and see how it runs. So once this is finished building, we'll be able to see a little runner, and I'll be able to say the word Imagine and it will show up in the right column, fingers crossed. Now, bear with me while this finishes building. Usually takes a couple of seconds. The other nice thing is you can do this on your mobile phone and you can take it out with you in the field. So if you want to show your friends how your model runs, you can also share the QR code with them and have a play with it on your phone. So we're almost done with the compilation. Here we go. So if we give access to my microphone, Imagine, there we go. And then the other nice thing is that all of my unknown words, just me talking, get shown up as an unknown. And then if we stop talking, we'll get some noise. And if I say Imagine, then we get the Imagine coming up. So there we go. We've built a model from scratch in a record time in under 5 minutes. And if we were to run it in real time on our Nordic device, we look at around 260 milliseconds inferencing time, 168K of RAM and 587K of flash. But if you wanted to go and deploy that to another device, there's a real wide range of different options. So at its core, our models can be compiled into a C++ library, which will run functionally anywhere. But we also have a bunch of different vendor libraries available for different hardware targets. And if your hardware has an accelerator inside it, like the Ethos line of accelerators from ARM on MCU, or say a NVIDIA accelerator or a Qualcomm accelerator, we have libraries to take advantage of those as well. We also have a bunch of different pre-built firmware available for a really wide range of development kits. So say you've got an Arduino, we might be able to build you some firmware that allows you to test directly on the bench. But if you're running on more powerful hardware like a laptop or a Linux device, we have Docker containers and Linux executables that make it really easy to run your model there too. So once you've built your model, you can go and deploy it wherever you like on the very smallest of hardware, all the way up to the latest and greatest. Now, that has been a little overview of how you can get started with Edge Impulse. I'll just jump back into the presentation and show you that sign up link again. So if you want to have a go at this tutorial yourself, please feel free to scan that QR code, sign up today. And I've been Jim, one of the solutions engineers at Edge Impulse. Stay tuned for some more really interesting sessions across all of the different tracks today. And stay here if you want to ask any questions about getting started with Edge Impulse. We'll be around to answer your questions now. Thank you very much for listening and have a great day.